Let f of x equal the piecewise function 4 if x is less than 5, and 9 minus x if x is greater than or equal to 5. And let capital G of x equal the integral from 2 to x of f of t dt. Goodness. Part A. Calculate g of 2 and g of 7. Hint, it may help to sketch first the graph of f of x. Okay, it's not clear to me how that's going to help, but Ian and Caitlin seem pretty smart, so let's blindly trust them on this one. So we'll go ahead and first sketch the graph of f. So we've got this piecewise function. It's constantly 4 until we get up to 5. So horizontal line up here at 4 until we get over to here at 5. Empty hole for the time being. And then it's 9 minus x when x is greater than or equal to 5. So 9 minus x is just a downhill line. All we need is to draw 2 points to figure out where that line is. So for example, if you plug in x equals 9, then you will find that the piecewise function is 0, right? 9 minus 9 is 0, so that's 1 point, 9 comma 0. And it seems like the other natural point to pick, well, one natural point anyway, is 5. We want to know what's happening when the rules change. So if you plug 5 in for this x, 9 minus 5 is 4. So that means that the point 5 comma 4 is on the graph of the diagonal line. And that actually means this hole gets filled in. And the point is either there or it's not, and it is. So that right there is the graph of f. Okay, so now we're supposed to find g of 2 and g of 7, and somehow that graph is supposed to help us. Okay, let's start with g of 2. According to the definition, it's this definition right here, g is equal to an integral from 2 up to x. So let's use that definition. Integral from 2 up to x. X in this case is 2. So this is the integral from 2 up to 2 of f of t dt. Okay, so for this part of the problem, I could care less about the graph of f because the integral from a number to itself is always 0. That part's easy. Maybe the other part will be harder. So let's see, g of 7 is the second part. So let's try that one. G of 7 equals, okay, same function. It's the integral from 2 to x. So now it's the integral from 2 to 7 of f of t dt. Okay, so the integral from 2 to 7 of some function represents the area between that function and the x-axis. It's really a signed area, right? If things go below the x-axis, we know we have negative, quote, area. Okay, so this is the integral from 2 to 7 of the graph that's pictured. So let's go out here to 2, someplace around here. That's where the area starts, and then it ends at 7, which I guess is right there in the middle. And so the space between is exactly the area in question. So somehow we are after the area of that kind of funny shape. Okay, but that's not really a calculus problem anymore. So we've translated this integral from 2 to 7 to represent an area. And now it's just a simple geometry problem. So let's see if we can't calculate that area. Okay, so let's maybe cut this shape up. So how about we have a rectangle on the left and a trapezoid on the right. So the area of this rectangle on the left, the base is 5 minus 2, so that's 3, and the height is 4. So the area of that rectangle is 12. So far, so good. So we're going to have a 12. It's positive because it's above the x-axis. Plus, and then we got more positive stuff. So the next shape is a trapezoid. So if you're feeling fancy, you can just use the area formula for a trapezoid. But if you're not feeling so fancy, I suppose you have to cut this shape up even further. So maybe here is a natural place to cut. So I guess we need to know what the coordinates are of that point. So how do we find it? Well, x is 7. That's the rule when x is 7. So 9 minus 7 is 2. So the coordinates of this point right here are 7, 2. And we need that in order to calculate some areas. Okay, great. So let's find some areas here. All right, so the area of the box, the rectangle right in here. Let's see, the base is a 2. The height we just calculated is also a 2. So I suppose that makes the area in here 2 times 2 or 4. And then focusing on the triangle at the top. So let's see, triangle formula. We lost too much stuff. Oh, this is unfortunate. Okay, so we had 2 times 2 is 4. All right, so focusing on the triangle, it's half the base times the height. The base is this distance, which is a 2. The height is this distance. It's not a lot of work, but a little bit. The top is 4. The bottom is 2. Difference there is 2. So the base and height are both 2 for that triangle. So then the area of the triangle is half of the base times the height. So crunch that together, we just get 2. So then smushing everything together, 12 plus 4 plus 2, 18. And that's the value of this funky function g of 7. Okay, so let's try part B. Calculate g prime of 2 and g prime of 7. Okay, so believe it or not, g prime of 2 and g prime of 7 have nothing to do with g of 2 and g of 7. When we're calculating the derivative, forget about how complicated the function g looks up here, but if you're calculating the derivative at a particular function value, you need to find the derivative in general before you evaluate at the particular value of x. So just as a quickie example here, if we said that f of x was x cubed, and I said find f prime of like 1, you don't get to plug 1 in yet, right? You have to first find f prime of x. And that's 3x squared. And then you say, okay, now I know what the rule for the derivative is anywhere, so then I can plug the 1 into that derivative function, right? But the important thing for this easy example is that we don't get to deal with the 2 and the 7 immediately. We have to find the derivative g prime of x first. So let's see if we can do that calculation in general, and then it'll be a simple matter of just plugging in the 2 and the 7. Okay, so here we go. G prime of x equals. All right, so let's go back to the definition of g. I'll highlight it up here in green. So g is that function, and I'm looking for the derivative of that function. And oh my goodness, that is frightening. But the derivative of that function happens to have a very particular form, and that particular form is quite friendly when it comes to using the fundamental theorem of calculus. So I'm going to scroll up here to this thing in blue from a previous problem. And so let's look at it. So it says if you take the derivative of this very particular kind of thing, integral from some number up to a variable x of some function, just h in this case, then you don't have to do any derivatives or antiderivatives. All you do is take the x and you plug it right in there, and your answer is just h of x, not t anymore. Derivative and integral are, in a very real sense, opposite. They cancel. The dt is part of the integral sign, so everything just explodes and disappears, and you just get the original function h evaluated at that variable. Lovely. So down here, let's get the green highlighted function up on the screen. There it is. Okay, so down here, we are looking for the derivative of, and then right in here, I'm just going to copy that green highlighted function, that g function. I'll put it right here, and then we'll see if anything good happens. Smart money is, yes, something good is going to happen. Okay, so we're trying to find the derivative of the integral from 2 to x of f of t dt. Oh, well, fantastic, because it's exactly what the fundamental theorem tells you how to do very easily. It says, again, that the derivative and the integral are inverses, and everything just goes away, and all you got to do is take your x and stick it right in there for the t. So let's do that. So this is really just equal to plain old f of t. I say again, g prime of x is, oh, I'm going to say it again because that was wrong. So what I forgot to do is take the t and change it to an x. So the derivative, g prime of x, is simply equal to f of x. Nothing more and nothing less. And now, again, the calculus is done, so the rest of this is going to be pretty straightforward. Here we go. We were after g prime of 2. Well, g prime of x is f of x, so g prime of 2 must be f of 2. Fantastic. So f of 2 you can find by either looking at a graph or by looking at the f rule, which we'll highlight in blue. There's your f rule right there. So how much is f of 2? Just plain f of 2, no derivatives. F of 2, well, let's see. Since 2 is less than 5, f of 2 is just 4. So this answer is 4. And then the other one is going to be almost as easy. The second part of this problem asks us to find g prime of 7, so we'll squeeze it in down here. Equals, according to the thing we just wrote in red, g prime of x is f of x, so g prime of 7 is f of 7. And f of 7, we go back up to our blue highlighted formula for f up there. 7 is greater than or equal to 5, so we're in the bottom rule, that 9 minus x rule, so we're just doing 9 minus x. X is 7 in this case, and so we just get plain old 2. So 4 and 2.